Hello my friends, this is your friend Brian and this is the part 2 of some selected exercises solution for introduction to probability. In the previous part I touched some questions and in this part I will touch the remaining questions of this chapter. So let's begin. The first question that we get is, let E and F be mutually exclusive events in the sample space of an experiment. Suppose that the experiment is repeated until either event E or event F occurs. What does the sample space of this new super experiment look like? So that the probability that event E occurs before event F is PE by PE plus PF. Now first of all let's try figuring the, like, in terms of set theory. Let's try seeing what this means. E and F are mutually exclusive. That means their intersection is zero. There is no intersection between the events. And uh, it is given that the experiment is repeated until either E or either F appears. So this means that the shaded portion is the experiment, means the shaded portion, let's call it this thing. Means this part is where it is repeated till either E or F happens. So we can say that probability that E or F happens is P is equal to PE plus PF. Okay, probability that either E or F happens is PE plus PF, because they're mutually exclusive. Otherwise we would have to subtract the intersection as well, but since they're mutually exclusive there is no intersection of them. So we can write this as, this becomes like, say suppose, means the question, it has been asked that uh, they are repeated until either of them appears. So technically it the experiment goes on for 1 minus p to the power n minus 1, means probability that the experiment ends at step n is into p. This is the probability that the experiment ends at step n. Now this can go till infinity as well, because, like, say suppose, uh, means this sample space keeps on repeating till infinite time. So the sample space will be like this, means uh, it has an infinite sample space. I'm not touching on that because it is very obvious here. So still, if I try to touch, it would look like this, like, what is the possible event that, let's say, this 1 minus p, let's denote it as p dash, means p complement. So it can look like this: p complement p, then p complement p complement p, then so on, like, there can be p complement 10 times, like p complement 10 times, and then there is p, like that. So let's not touch on that. Now the question is, and since the sample space idea is clear, let's see what does it is given that, what is the probability that event E, that is PE, occurs before uh, PF. Means if PE appears, then the experiment will terminate. So that means that in what scenario PE comes first before PF. It can be that in the first attempt only we got PE. Okay, then other thing can be that there is one time it didn't come, then this came p, then p complement p, like this. So if you notice the pattern, this is basically saying, if there are like n events, this is basically 1 minus p to the power n minus 1 and pe. This is the probability that PE happens before PF happens. So if you notice, this is actually a geometric progression series, uh, and this is an infinite series because it can go on for infinite. So the sum of an infinite GP is like this. Yeah, it is the formula for an infinite GP is summation of like if I do a summation of all summation of p means total chances, like these are pe. Actually I should have written it as pen, because what is the chance that after n steps e appears before f. So summation will give the actual entire probability, which is summation formula is like this: summation of gp a1 by 1 minus r, where a1 is first term, meaning the first term here is let's put it as 1, then we get pe. The first term is pe, and then the last and after that so yeah, a1 is p, and r means r is the common complement, means the factor with which we are multiplying. So here the common complement is this part 1 minus p. With every successive step 1 minus p is being multiplied, like for the 1 it will be 0, then for 2 it will be 1 minus p into p, then for that 1 minus 2 whole square into p, like that. So the common complement r is 1 minus p. So S is equal to A1, that is PE of P by 1 minus 1 plus P, means minus into minus is plus, so this will be like this: PE by P equals to PE by PE plus PF. So that we can see that the end product PE by PE plus F matches with this part P by P plus PF. So we can conclude that this part has like we have proved this part. So this question is over. Let's proceed to the next question. The next question is, suppose that 5% of men and 0.25% of women are colorblind. A colorblind person is chosen at random. What is the probability of this person being male? Assume that there are an equal number of males and females. So first of all, let's see the male population. There is the female population. The chance of a person being male is half, a chance of a person being female is half. Now 50 out of the 50% male population, 5% of men are color blind. So that is half into 5% means 1 by 20, 1 by 20. So this is the total percentage of population which are male and color blind. So this is 1 by 40. Now coming to the female section, 0.25%. So half 0.25 means what? 0.25 means 25% means 1 by 4. So 0.25 means 1 by 400. 1 by 400. So equals 1 by 800. So what we can see from here is that total percent of the population which are colorblind and male is 1 by 40, and let's call it CB. Colorblind and male is 1 by 40, and total part of the population which is colorblind and female is 1 by 800, means probability colorblind and female Okay. Now, what is the total chance that a person in the population is colorblind? So 1 by 40 plus 1 by 800. If we add this, 1 by 40 plus 1 by 800, because this is we are simply adding it because the events are mutually exclusive. A person can't be male and female at the same time. So the total uh, these are means these events are mutually exclusive. That's why we are adding them to find the total probability of a person being colorblind. Colorblind is equal to this part plus this part. That is what we get is 800 will be denominator, 21 by 800. 21 by 800 is the chance that a person in the population is colorblind. Now the question is given that it is known that they are colorblind. What is the probability a colorblind person is chosen at random? Like, it is known that they are colorblind. So from the formula, what do you know? Let me erase some of this. So from what we know is that, let me clear it. Yeah, a little more clearing. All right, this much is fine. So what we know from this is that the person is already colorblind, and it has been asked that it is a male. So PM, like Bayes theorem, right? So by Bayes theorem, this is this. That means PCB intersection M, colorblind and male, by PCB. This is it. So what we found was colorblind and male is 1 by 40, and this is 21 by 800. So if you know basic mathematics, it will be like 1 by 40 into 800 by 21. I hope I am doing it right. So this this a wait 80, right? So it will be like 80 will be the, okay, it is this thing 10, I can cut it here, 20. So the answer is, the probability that a person who is colorblind is male is 20 by 21. That is nearly, if you do a percentage thing into 100, you will see that 21 is like how much? Let me calculate. Like 21 fours are 84, and 16 84 4 and 20 into 4. Okay, let me get the my calculation has become weak. 20 by 21 into 100, right? So if you are asked, this will be this. 21 800, 20 by 21 into 800. This was it, right? Sorry, what the fuck am I doing? I'm really sorry. Like 20 21, 20 by 21. This is this. Again, what am I doing? 21 by. Let's leave it at that. Like you can do it for yourself. 20 by 21 into 100. This is the percentage of people. This is the percentage of people who are colorblind and uh, are male. Percent. So let's proceed to the next question. So in this current question, it has been said that A standard deck of 52 playing cards containing all four aces, spades, heart is randomly divided into four piles of 13 cards each. 13, 13, 13, 13. These are the like 52 cards divided into four this thing. Now it is given that events are given E1, one of the piles contain the ace of spade. What is the probability? Wait, let me read the full question. E2 is the ace of spades and the ace of hearts are in different piles. Means ace of spades and ace of hearts are in different piles. Ace of spades, ace of hearts and the ace of diamonds are all in different piles. And finally, all four aces are in different piles. Find the probability that the aces are distributed so that no two aces are in the same pile. So the question is, find the probability that the aces are uh, distributed so that no two aces are in the same piles. Now let's proceed with this. Probability for E1 is that it is in one of the aces, one of the this what is it? One of the divisions. What is the probability that one of the piles contains ace of spades? So total number of cards that are in any of the piles is 52. Total number of cards is 52. So the probability that one of the piles contain the ace of spade is 1. Now let's go to the second one. We have already given ace of spade in E1. Okay, now E2, ace of spades and ace of hearts in different piles. Now we have already put the ace of spades in one pile. Now in this other piles we have to put ace of the hearts. So how many cards are left? 51 cards are left because we have already put ace of spades. And how many eligible cards are left? That is 52 minus 13 because one pile has been eliminated, so that will be 49 by 51. So this is the probability for this. Now for E3, the probability that this thing like 50 cards are left and 49 minus 30, 36 cards are left. So and E4 is for doing this like ace of heart is not means ace of heart, so ace of diamond is also done. Ace of club is in a different this thing. The probability is oh, wait a minute, for 49 minus 13 is 36, 36 minus 13, 13 fours are 52. Yeah, 13 fours are 52, 52 minus 30. Oof. Sorry, I did a mistake. This will be, that's why I was thinking of what was going wrong. So this will be like 39. This will be 26. So the final is 13 by 50 minus 1, that is 49. So the probability that aces all aces are in different piles is E1 intersection E2 intersection E3 intersection E4, which is uh, which is basically 1 into 39 by 51 into 26 by 50 into this thing. This is 13 by 49. This is the answer. This is the probability that every ace is in a different car ace is in a different distribution. So I am not calculating because it will be a waste of time. The next question is, suppose all n men at a party throw their hats in the center of the room. Each man then randomly selects a hat, so that the probability that none of the n men selects his own hat is this equation. So let's first try to understand what is happening here. Firstly, there is one man. He's throwing at his hat. Okay, he's throwing at his cap. I'm drawing cap. The second man is also throwing at his cap. Then there is a third man. He is also throwing out his cap. So these people throw their caps. Now he picks up his cap. He picks up his cap. He picks up his cap. Okay, everybody got a wrong cap. Now the other thing that can happen is, instead of he picks his cap, he picks his cap, and he picks his cap. Like, these are the ways to pick up a wrong cap. Now since the situation is clear what is happening, let's try to see things numerically. Numerically what is happening is that, so not numerically, where in terms of a Venn diagram, what is happening is, this is the entire sample space and this is the event A, where one person picks his, means person A is picking his hat correctly. Now this is the probability that person B is picking his hat correctly. Now this is the probability that person C is picking his hat correctly. So what is the probability that none of them are picking correctly? That is this portion, that is S minus A union B union C, right? So now A union B union C, as we know, is this: A union B is A plus B plus C minus A intersection B intersection A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C, right? Because when we are deleting this portion, means sorry, when we are adding this portion, we added this portion. Now when we are adding B again, we are deleting this portion, this part. Now this is like this, this is like this. Now when we are adding C again, we are adding this portion and this portion again. Let me change the ink. we are we are adding this portion and this portion and this portion again. So what we are doing is, we are deleting this portion, this part. Let me choose the ink. We are deleting this part, we are deleting this part, but what we did is, we again deleted this part by, like, the middle part, different ink. Okay, what we did is delete this part again, so at the end we add it. Now let me remove it and uh, try to show it in terms of, like, combinations and stuff like that. Let me try to show. Okay, I will need to draw that part again. This is the probability that A, B, C, then let's add another one, D. Okay, so what is the probability that this thing, means we have to calculate this part, right? Now what is the answer? PS minus P of A union B union dot dot dot, let's say n. Okay, where where n is the final number. Now uh, these are the sample spaces, A union B union. We have to remove this part. Now first of all, let's try removing uh, every sample space where one is correct. Like, one is correct, that can be either A, like, say, suppose, let's say a, 1 is correct. That can be either a, b, c, d, like that till n. It can be anything. Now what is the probability that at least 1 is correct? Before that we need to do ps is obviously 1, because probability of s is 1, sample space is 1 is an axiom we learned in the previous videos. So what we now do is that first of all we did, now let's find this p of 1. 1 is correct. 1 is correct is probability that 1 is correct is 1 by n factorial by n minus 1 factorial. Like if 1 is correct, then the remaining can be arranged in n minus 1 factorial. So this is the number of sample spaces where 1 is correct, means not 1 exactly, a is correct. Now instead of just a, we want to do it with every sample space out there, like a, b, c. Probability that any one of the all the sample spaces, not sample, all of the elements, any one is correct. What is this probability? The probability will be like uh, we have to do an nc1, that is nc1, which is basically n factorial. N factorial into, sorry, not n factorial, that is n, sorry, means nc1 is n, so n into 1 by n factorial of not n factorial. It means n minus 1 factorial, when it divides n factorial, it becomes n, right? So this part, the first part becomes 1. Now this we are like for first this is one part we are dividing, at least 1 is correct, we are removing it. Now you have to understand that when we are adding all of this together, like first we added a only, now then we added b like this, then we added c like this, means this part contains all the cases where at least one is true. It contains each one of them. Now we have to remove the redundant part, that is like, say suppose where 2 is correct, okay, the number of cases where 2 is correct out of this is uh, n minus 2 factorial by n factorial, that is basically nc2 is basically n into n minus 1, then n into n minus 1 by 2 factorial into 1 by n into n minus 1 is equal to 1 by 2 factorial. So what we can see is that let's go to the next slide. What we can see is that in this thing, firstly we are removing from the sample space 1 minus 1 plus 1 by 2 factorial. Then after that we have to remove every case where like 3 is correct, means see basically what happens is, what is 3 are correct, 3 are correct means this part, right? So what is 3 is correct? 3 is obviously a subset of 2 is correct, like here 2 is correct, here 2 is correct, here 2 is correct. Now you have to subtract this part because they have been added multiple times, so minus 1 by 3 factorial. Now after that you have to like you have to do this like you have to add every part where 4 are correct, 1 by 4 factorial, and like that it will basically go for minus 1 to the power n, means dot 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 plus minus 1 to the power n by n factorial. This is what it goes on like. So ultimately it will become 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, like that, dot dot dot, plus minus 1 to the power n by n factorial. That is the n factorial, yeah. This is what it is. So this is ultimately, this is what we are getting, and the value for this is ultimately is equal to e to the power minus 1. Okay, so this is what we are getting. Let's move to the next part. The next question: a fair coin is continually flipped. What is the probability that the first four flips are head, 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 tail, head, 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 and what is the pattern is? Okay, let's do it one by one. Probability that first four are head is half into half into half into half, 1 by 16. Okay, now the probability that this is tail into a, this is again half into half into half into half is equal to 1 by 16, because this part is probability for tail, this part is head, head, this part is tail, head, head, head. So now the question is, the C part is the interesting part. What is the probability that the pattern THHH occurs before the pattern 4H? Now in what cases that does 4H, means in what cases that T triple H occur before this thing 4H? The only cases that happens is when in the beginning, if the first flip is 4, the first flip is H, second flip is H, third flip is H, fourth flip is H, like this, then only you get where T comes before this. Now you may argue that T infinite is, it is going, T infinite is going, but like if it is going continually, say suppose ultimately it, means the pattern has to stop somewhere. The pattern stops at either T triple H or T 4H. Now if 3H comes anywhere other than the first position, there will always be a T there. Like if there is, instead of T there is a H, then it will become 4H, and 4H means this is not the means first, not the first 3H, then this 3H will be considered, then there again will be TH. So ultimately the only case where 4H appear before T triple H is the first case, that is H, 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 H. Now the probability for getting this thing is 1 by 16. So the probability of getting this thing is T triple H pattern before 4H is 15 by 16. Alright, this is the only place where you can get. Now let's go to the next part. 60% of the families in a certain community own their own car, 30% own their own home, and 20% own their own car and their own home. So basically, the probability that you own your car, the probability that you own your home, and this is both, they are owning both. So what is this? PC plus PH, you own your car, you own a home, is equal to 60 plus 30%, right? 60 plus 30% is equal to 90%. Now you have to reduce this part from it. So if you reduce this part, you get is what it is given, 20% own their both home and car, so 70% own either car or home. Now the question is, what is the probability that this family owns a car or a house but not both? So basically we found out that C union H means this thing is 70%, like 7 by 10. Now we also know that this place is 20%, that is 2 by 10. So the probability that they own either this or that but not both is 7 by 10 minus 2 by 10, because this part is owns both, so it is 5 by 10. So this is ultimately 50% people own either car only or home only. Now if you want to see what percent owns home only, that part is like 30 minus 20%, that is 10% of the people own only a home. Maybe they inherited it from their parents or something. Then the people that own their car are 60 minus 20, 40% own only a car. So 40 plus 10% is 50% own only a car or own only a home. So proceeding to the next. Okay, luckily there are no more questions in this series. Now see the hat problem. uh, I honestly know that I couldn't explain it very well, so if possible I would try to explain it once again in the future, because like uh, it is leaving a bad taste in my mouth that I wasn't able to explain it to you. And believe me that solving it myself was also like, uh, if I try to explain it like this, and I'm not solving it, just I'm trying to explain how this works, is basically this thing, this A union B union C union, like this. There is again this place. The thing that is happening basically is uh, means when we are removing, first of all we are selecting one person is correct. Now we are selecting any of the one person who is correct, like 1 2 3 4. Means when we are doing this thing, that is uh, nc nc1, that is any of the 4 person, like we are selecting this circle, this circle, this circle, this circle, we are selecting all of them. Now you will see multiple parts are getting added multiple times, like this part got added once more, then uh, this part got added, this part you can see, let me change the ink, this part got added twice, then this part got added once more, means once more, then this part got added twice, the with this and this, means 2 times extra than it actually exists. Then this part has been added once more, then this part has been added like 1 2 3. So this is twice more, this is once more, and this part is like 3 times more. So ultimately we have to remove them. Now when we remove something, like in high school maths, if you remember set theory, there was this thing like minus, let me change the ink, A union B is equal to A plus B minus A intersection B. Then there is A union B union C is like A plus B plus C minus A intersection B minus A intersection C minus A intersection sorry B intersection C plus A intersection B intersection C. Then if you do it to fourth, you add one thing more, A inter union B union C union D. It becomes like A intersection B plus means A plus B plus C is equal to A plus B plus C plus D. And then you subtract this A intersection B part, then you subtract A intersection C part, then you subtract A intersection D part, then you subtract B intersection C part minus B intersection D part. Like this, you subtract these parts. Then after that, is anything being left? A, B, C, A, D. Okay. Then AB is there, BC, BD. Okay. AC is there. Okay. CD is missing, minus C intersection D. Then you are doing this like plus A intersection, like you are adding A intersection B intersection C plus A intersection B intersection D plus A intersection C intersection D. Then you are adding B intersection C intersection D. So then ultimately you are subtracting A intersection B intersection C intersection D. Like ultimately this is actually something called inclusion exclusion principle in probability, and I will try to explain it better in probability terms. Like I was trying, but right now I couldn't. In the future I will try to explain this hatter problem in a very simple manner. Like my philosophy is that I should try explaining something very simply. Means rather than making it complex, it should be simple, right? So let's try. Mm, See you around. I hope you didn't mind. Like you might try searching about it yourself. This is a classic problem called the hat problem, classic in hat problem. You can read it about it yourself, and if you find something, you can definitely comment about it. Thank you for like watching my video, and please, if you can solve it yourself, please do try explaining it in the comments. Thank you.